Okay, welcome back to Calculus 2. We are looking at our final exam review. So here we have the integral of 10x over 16 plus 25x to the fourth. There's no kind of u substitution that's going to help this out, but this is a square, that's a square, and that's giving me something. It looks like there's some kind of squares going on down here. So my first little substitution is going to say, how about we let u is equal to x to the 4, or x squared, right? We'll try it that way. And we'll say du is equal to 2x dx. What that's going to do for me, let's just see, follow this through. So I've got a 2x that I need, so we're going to reserve that. So I've got a 5. Here's my 2x dx. On the bottom, we've got a 16 plus 25. Instead of x to the fourth, I'm going to say u squared is equal to x to the fourth. If I square this, we're going to end up with u squared. That's looking to be like an inverse tangent, okay? So right here, we're going to pull this aside. We're going to say, hey, I've got a 2x dx here. We've got 5 integral du over 16 plus 25u squared. Now, I don't have a square root, but I do have a squared thing. So this is still reminding me of triangles because I've got an a squared plus b squared kind of a thing going on here. So let's go ahead and see what happens. So if I go ahead and make a little triangle, we're going to go ahead and set that up. So we've got to take square root. So it's got 4. And here we're going to have 5u. Here's my theta. And this is going to be the square root of 16 plus 25u squared. Not quite, but close, right? So my tangent of theta is equal to 5u over 4, okay? Or u is equal to 4/5 tangent of theta. So at that point, we're going to say du is equal to 4/5. Derivative of tangent is secant squared theta d theta. We're just going to hold that off to the side here. Okay. As I'm looking at my triangle, I'm going to say that cosine of theta is equal to 4 over the square root of 16 plus 25 squared. That's close. That's not quite what I want, right? Because I don't want the square roots down there. But if we squared our cosine here, so if we say cosine squared theta is equal to 16 over 16 plus 25 u squared. That's kind of what I'm looking for, okay? And at that point, I'm going to go back into my whole thing here, my whole integral, and see what's going on here. So I go back up here and I say, okay, what's happening here? Go up. So we've got our du. So I'm going to put the 5 out in front here. So I've got 5, and then my du is equal to, so we've got 5 integral. What's my du? It's 4/5 secant squared theta d theta times. And now what I'm going to do is I'm going to say, hey, if I multiply here by 16 and divide by 16, right? So we have 16 up here. We have 16 down there. That's going to be 16 over 16 plus 25 u squared, 25 u squared here. So we're going to go ahead and put the 16 down here. I put a 16 up here. So we have 16 over, and that's equal to cosine squared theta. Well, something special happens when you got cosine squareds and secant squareds, and that is that these guys cancel each other out. So we've got a 5 canceling out here. So this is going to be equal to, this 4 cancels with that 16. So I've got 1/4. Secant squared and cosine squared, they all go away. So I just have integral of d theta. And that's a physics integral if I ever saw one. Okay. So we're going to be looking at 1/4 theta plus c. Now, if I go back up here, we've got tangent of theta was equal to 5u over 4. So we could say that theta is equal to, let's go back up here. So, yep. Theta is equal to the inverse tangent of 5 over 4, 5u over 4. So let's go ahead and replace that. So we're going to say we have 1/4 tangent inverse of 5x squared, because that was my u, right? Over 4 plus c. And that's the answer I'm looking for this problem. Okay? Yes, there's other ways to do it, but usually you have a 1 over something squared plus something else squared. You're looking for an inverse tangent. And lo and behold, we found one. Okay? Well done. That's how you do this kind of a problem. I'll see you in the next one. Keep studying. Okay? Thank you very much for watching my video.